The wireframe modifier will convert any mesh into a wireframe, effectively deleting the faces and replacing the edges and vertices with its own series of faces to create a wide mesh. To access the wireframe modifier, go to the Modifiers tab in the Properties panel, and from here select Add Modifier, Generate, then come down to where it says Wireframe and left click. This will add the wireframe modifier to your existing model. The idea of the wireframe is to replace the original mesh with a new wire-based mesh that takes into account the location of the existing vertices and edges of the original model. Here I'm going to just increase the thickness parameter so you can see what I'm talking about. We've been able to use the wireframe modifier to generate a new mesh from the structure of the old one. This new mesh creates faces that surround all of the edges and vertices of the original. Let's take a look at this on a couple of other models. So I'm going to move this along the y-axis, and then I'm going to add a new object, let's say cylinder. We're going to add modifier, generate, and select wireframe. Again, this takes into account all of the existing vertices and edges and creates a new wide mesh based on their locations, positions, directions of normals, etc. Now let's create one more example, perhaps a little bit more complex. This time we'll add a monkey mesh. Let's just rotate it on the z-axis, add modifier, generate, wireframe. And again here, we can see that we have taken all of the existing edges and vertices to create a wide mesh using this modifier. This modifier can easily be used with other modifiers in the modifier stack. For example, we can combine this with the subdivision surface modifier. Let's attempt this with our cube object. So we don't have a lot of geometry here to work with, so it's going to make for a good example. We're going to add modifier, generate, and select subdivision surface. Now this is going to subdivide the geometry of the wireframe, because the wireframe is affecting the model first, and then the subdivision surface is affecting the wireframe. We can increase the number of levels if we want to create a smoother effect. But this is going to be a completely different result to if we were to reorder the wireframe and subdivision surface modifiers. So if I was to replace wireframe with subdivision surface at the top, we actually end up with a completely different result. Here we are subdividing the original model first, and then we are creating a wireframe from the subdivided mesh. Another modifier that we can combine with our wireframe is the Bevel modifier. So I'm going to remove subdivision surface and replace it with the Bevel modifier. Again, when the Bevel modifier is below the wireframe, Blender is going to create the wireframe's geometry first, and then use the Bevel modifier to smooth out the geometry of the wireframe. If we were to revert to the bevel going first, then it creates the bevels on the original cube, and then it takes those beveled edges and converts them into a wireframe. So again, with the modifier stack, we end up with two very different results by using the same two modifiers. The wireframe modifier is most similar to the wireframe tool. So as a recap as to what the wireframe tool will do, we're just going to hide the objects that we've created, and let's create a new one. This time we'll create a UV sphere. We'll hit the tab key to go into edit mode, and if we take a look at some of these menus here, under face we should have the ability to create a wireframe. So I'm going to left click and this will generate a wireframe mesh from our existing geometry. I can open up the outliner panel and manipulate many of these parameters. For example, we can add some thickness and maybe change the offset a bit to create a new final result. But again, because this is not a modifier, when we use the wireframe tool, the process is a permanent one unless we decide to use Ctrl Z to revert back to the original state. Now let's take a look at some of the parameters of the wireframe modifier. First of all, the most important one is going to be the thickness. This, as you would have guessed, is exactly how thick the individual areas of our wireframe are going to appear. So, if we were to click and drag to increase the thickness, then you can see that happen in real time for each area of our wireframe. If we lower the thickness, we'll get the reverse effect. So you can manipulate the thickness value to get a wireframe that looks exactly how you want it to. Below that, we have the offset parameter, and this determines where the new geometry is going to be generated in accordance to the location of the original edges. When the offset is set to 0, the wired geometry is going to be generated around the original location of each edge and vertex. If we were to increase the offset value, then you might notice that the object gets slightly larger, and I'm going to increase the thickness so that this is a little bit more visible. What's happening here is when the offset is set to a higher value, the geometry is being generated towards the outside of the original mesh. If we reduce this value into the negatives, then the wireframe geometry is being generated on the inside of where the original mesh should be. The wireframe modifier is one of those modifiers that is heavily impacted by things such as transforms. For example, the scale of your models can impact how the wireframe affects those models. For now, I'm just going to select and hide all of our geometry. Oh, I just deleted it by accident. Press the H key to hide. And then I'm going to add a plane object. And for this plane object, I'm going to, first of all, go into edit mode and subdivide 5 times. Then I'm going to duplicate that same object, move it over, and each of these I'm going to scale by a factor of 3 on all 3 axes. However, the first one I'm going to apply the scale, but the second one I am not. So I'm going to hit Ctrl A and apply the scale of my first object. And if we look in the side panel, you can see all 3 of these scale values are reset to 1. But for the second plane object, they are currently set to 3. Now I am going to add the wireframe modifier to each of these objects. This is the first one where we had the scale applied. And take note of the thickness value here. So it's set to 0.2 meters or 0.02 meters for our object. Now for the second plane, we're going to add the wireframe again, but immediately you should spot that the thickness is far greater with the second wireframe compared to the first. Even as we orbit our view, you can really see how much thicker the wires are with that second plane. The reason why is that the thickness value in the wireframe modifier takes into account the scale value. So it will use the original base value you set here, which in this case is 0.02 meters, and it will adjust that based on the scale of the model. Because this has been scaled up 3 times its original size, the actual thickness here is going to be 0.06 meters for the wireframe instead of 0.02 meters. So keep that in mind when you are going to use a modifier like wireframe on an object that hasn't had its transforms correctly applied. The boundary option is used to generate additional geometry where we had the original boundaries of the model. In these examples, we basically had a plane object and we subdivided that plane, but the boundaries are still the same as they move around the edges of the plane. By default, this option is not ticked, and that means if we zoom in on these boundaries, you should just about make out the fact that we've not actually generated additional geometry here. By comparison, if you look at any of the other areas of the wireframe that we used by subdividing the mesh initially, you'll see that geometry has been generated on all sides of where that original edge was going to be created. So with that said, let's take a look at what happens if we tick the boundary option. When we do this, we're going to generate geometry around the boundaries of our model, around the outside edges, that looks a lot more like the geometry we created for the rest of the wireframe. So there are going to be a lot of scenarios, such as here with these wireframe based planes, where you can use the boundary option to create the added little bit of geometry that goes around the outside of the mesh. Here we're back with Suzanne, and for an object like Suzanne, there aren't really any boundaries to speak of. It's mostly a single cohesive mesh. However, if we were to move into edit mode, deselect everything and press the L key, you would see that we have 3 different islands. Now each of these islands, the 2 eyes and Suzanne itself, are going to have boundaries in certain areas. So the eyes are fairly obvious. If I press L then G to just move outside, you can see the outside edges at the back. That represents the boundary for this eye. So in this case, focus your attention in particular on the eye area. So I know there's a lot of geometry, but just keep an eye, pun intended, on the eyes. So left click to enable the boundary, and you should just about see at the back here that we get some new geometry forming as a result of ticking this option to create those boundaries. We then have the option to replace original. This is going to be ticked by default, and this is for when you are using the wireframe instead of the original model. Watch what happens though if I untick the replace original checkbox. The faces used to create the original model have returned, so the geometry here is actually maintained underneath our wireframe. If we bring in another object, let's say our cube and cylinder, we'll select the cylinder, we can untick replace original, and it's going to bring back the original geometry. Now in this instance, we can't see the wireframe. Now you may have noticed within the properties panel that the offset for the wireframe is set to -1. So if you want to use both the wireframe itself and the original geometry, you're going to want to set the offset to a value that makes sense. So that could be a value of 0, which may result in some overlapping geometry, but a cohesive shape. Or you could set it all the way to +1 so that the entirety of the wireframe will show up on the outside of the original object. When it comes to the thickness values, we can choose to initiate an even thickness or a relative thickness. Now you might see these terms in other modifiers, and these can mean different things with each modifier. When it comes to the wireframe, even thickness will scale the offset value so that it accounts better for sharp corners, which is the case for this cube. As a result of this, the quality of the wireframe can improve, but it's also slightly more performance intensive. Now normally what will happen if you tick on the even option, is that your wireframe will actually get a little bit of additional thickness. But you should also be able to see that the structure of the wireframe is a bit more consistent or coherent in those corners. In a lot of cases, I like to have this kept ticked on, which it typically is by default. The second option is the relative option, which scales the offset by the surrounding geometry. What this actually means is that it takes into account the length of the original edge to determine the thickness. In the case of our cube object, for example, all of the edges that were used to create that object are of the same length. We can turn on the relative option, and this will increase the thickness of all of these edges, taking into account the length of each one. But because they're all the same length, the thickness is going to be the same across the board. So keep in mind that when we have relative thickness turned off, we have a thinner wireframe, but when we have relative thickness turned on, we have a thicker wireframe. However, this is not always the case. Let's take our cylinder, for example, which has smaller edges used to create the top and bottom, and then we have the vertical edges used to create the structure of the cylinder itself. I'm going to click on the Replace Original option and deselect everything so we can get a good view of our geometry. And if we were to untick the Even Thickness option, the geometry appears to be a little bit smaller because it's no longer taking into account the corners, which are effectively all of the intersections that go around our cylinder. But let's see what happens if I turn this on and the relative option on as well. You may see that the geometry actually gets a little bit smaller, or the wireframes get smaller compared to the cube, where turning on the relative thickness actually made it the wireframe larger. And this is partially because of A, the length of the edges used for this model, as well as the number of edges used for the model. So these factors are all taken into account when you are playing around with the even and relative thickness options. Ultimately though, what you choose when it comes to applying even and relative thickness will depend on if you aesthetically believe that the geometry looks correct depending on what's applied. The option below the thickness is one that allows us to manipulate the creasing of edges when using the Subdivision Surface Modifier after the wireframe. So this is a property that has a very specific use case, and that's based on the additional geometry added using modifiers like Subdivision Surface. If we turn it on by itself, it's not going to have any impact on the model. What it's going to do is it's going to redefine how other modifiers function after the wireframe. So we're going to add Subdivision Surface, and you can see the effect that this has on the wireframe itself after we have added the wireframe modifier in the stack. So currently we have the wireframe first, then the subdivision. If we click and drag to replace, we actually get an entirely different shape, but at least we don't get the stretching of the geometry caused by Subdivision Surface when it's placed below the wireframe modifier. Now though, I'm going to enable the Crease Edges option. As soon as I do this, you'll see that the general shape of the model has reverted back to what it was before we added Subdivision Surface. If I increase the number of levels in the 3D viewport, what's happening here is that we're able to add more geometry to the existing wireframe, but we're no longer changing the overall shape of the mesh because of the Crease Edges option. We can determine the influence of Crease Edges by clicking and dragging on this option here, which currently says 1.0. This refers to the crease weight, and if we click and drag to reduce this, we actually increase the impact that the subdivision surface modifier is going to have on the curvature of our geometry. But remember, in most cases, when using wireframe, you're not really going to want to create this added curvature, which is why it's a good idea to use crease edges and set the value to 1.0 if you only want to use subdivision to increase the amount of geometry on the existing wireframe. We then have the material offset. Now this value here is linked to specific materials created within the materials tab of the properties panel. Currently we've created no materials, but if I click on the plus button, I can add a new material slot to our cylinder object and then create a new material. Let's name this first material as red and set it to a red color. Let's preview this material using the material preview shading. Now we can see that we've got the red material. What's important here is that each material is assigned a value or a material index. If we return to the wireframe modifier, that material offset is currently set to 0. But what happens if we create additional materials? For example, I'm going to create a blue material followed by a green material. Now each of these materials has a unique material index value. If we return to our wireframe modifier again and change the material offset value, we're going to change the color of our wireframe. Now this affects the wireframe specifically. If we untick the replace original box, then you can see that the original mesh is still a red color. So the material offset value here is equivalent to the material index value that is assigned to each material that we create in this location. Red has a material index of 0. Blue has a material index of 1. Green has a material index of 2. So if I increase this to 1, we get blue. If I set it to 2, we get green. If I set it beyond 2, then it will simply maintain the most recent material offset value, which is going to be number 2 for the color green. We have an additional section here for Vertex Groups. This allows us to only use the wireframe modifier on a defined vertex group. Now for our cylinder, we don't really have enough geometry to demonstrate this with. So I'm going to bring back Suzanne, where we have a lot more geometry to work with, and I'm just going to click on the replace original option again. But we're going to go into wireframe mode, where we're just going to select some geometry on our model and add that geometry to a vertex group. So in this case, let's add the 2 eyes and the nose. I'm going to just hold down shift to left click, and actually let's just start with the nose. I'm going to use Control and plus a few times, and I just want to select the geometry that I want for the vertex group. Then I'm going to press L to add the eyes. So all of this geometry is going to be added to our vertex group, which can be done so in the data tab of the properties panel. Come to where it says Vertex Groups, press the plus button, and let's just name this as Wire for now, and click Assign. Then return to the modifier, open up Vertex Groups, and in Object Mode, we're going to select this space and choose Wire. When we do this, we're creating the wireframe, but it is exclusive to the geometry that we selected for the vertex group, and everything else has actually been hidden. Well, I say hidden, but really if you think about it, because we didn't create a wireframe for the rest of the geometry, it's basically removed along with the rest of the model, which is the same as what we had when we just didn't use a vertex group and the entire model became a wireframe. The original mesh is replaced by whatever we want as our wireframe, and when we enable the vertex group option, we limit the areas of the model that are going to be affected, and the rest is simply going to be removed. If we untick replace original, we get back the rest of the mesh as we would expect, including the eyes and nose, but the key difference this time is that the eyes and nose now have their own wireframe that overlaps the original geometry. We can invert this effect using the invert button, which is located next to the vertex group option. Again, I'm just going to replace the original and then click on this button here to invert the geometry that I want to create a wireframe for. So now we've removed the geometry for the eyes as well as the nose. So we have 3 holes here on our Suzanne model, but we have again been able to create a wireframe mesh by using the vertex group as the reference. I can also again untick replace original, and here we've got a scenario where we've been able to create almost like an exoskeleton with our wireframe, but it doesn't hover over the nose and eyes, which kind of makes more sense depending on the style of model that we're trying to create. And then finally we have the vertex group factor. So I'm just going to replace the original once again, and as we increase this value, you'll start to see the geometry for the eyes and nose begin to reappear. They don't have the same thickness as the rest of the mesh, but as we increase that factor value, the added geometry on the eyes and nose gets thicker until we reach a value of 1. So if we have a factor value set to 1.0, it's effectively the same in this case as not using our vertex group. Again, keep in mind that we are also inverted. So if I turn off the inversion, you can see nothing's changed, but if I click and drag to reduce the factor value, now the wireframe that surrounds the rest of the face and not the eyes and nose begins to get thinner until we reach a factor value of 0, which removes the rest of the model entirely, other than the geometry defined by the vertex group. So that wraps up all you need to know about how to use the wireframe modifier. Don't forget to like, subscribe and hit the notifications bell icon if you want to learn more tools, modifiers and general tutorials on using Blender 3D. Thanks for now, and I'll see you in the next video.